any others who may be missing. I don't know if anybody will be missing the next one. Evan is so kind. All right, so since I've forgotten, almost started without you, we'll talk over, now that we've learned vocab, okay class, be brilliant. What does it mean if we're talking about the ambiguous case of the law of signs?
Something unclear and more than one possibility.
Yes, it is unclear, it has more than one possibility.
Like school lunches.
Like school lunches, okay. And we've already discussed over here that the law of signs actually works in 3 situations. It works when you have an angle side, an angle side angle, or, as we've already discussed, we will refer to it as side side angle. But, as you know from geometry, side side angle was not a theorem, so it's also for us, it's our problem. And in fact, it's what causes us to have this ambiguous case, where there's more than one possible triangle that could happen. So, how does this actually happen? I took off my notes. I'm going to attempt here to draw you a decent picture of this. All right, if I had started out with a situation here, well, we're going to work with a side-side angle situation. Okay, I am telling you right now that you know the measure of this angle. We're going to know the measure of this side out here. Where would the other side be that we have to know if this is going to be side-side angle? Yeah, it'd have to be this missing side over here. The bottom I just have extended out. Wherever the side up here on top ends up hitting it, that's what we get. Okay, and I'm going to actually use this with a ruler to prove it to you. So I'm sorry, people on the video, you can't see the ruler here. But suppose I said, okay, I want this other side over here is going to be 5 inches long. That long. If I come up here and try to measure from this top point, starting up here on the top point, if I try to measure out a 5-inch angle, or 5-inch side, is there any way measuring 5 inches that I'm ever going to get it to hit the bottom? It's never going to hit. And that's one of the problems with side-side angle. It might turn out that the 2 sides in the angle they gave you won't form a triangle. You can't make it be a triangle. So sometimes side-side angle, there isn't a triangle. It doesn't work. That's one possibility. Okay, a second possibility is suppose I change this line to maybe a 6-inch angle, 6-inch line. Okay, if I try to measure 6 inches up here, I can, well, actually, I should have gone just a smidge more than 6 inches. Okay, cheat, go 6.5 to make my point, because I can't quite reach it. Okay, if I go 6.5, I'm going to hit exactly once. It's going to form a triangle. That's going to be good. So sometimes side-side angle works, and please don't take. No, it's locked up. Oh, there we go. We caught it. Okay, so sometimes side-side angle means you can have one triangle, like normal. But here's the real kicker. Suppose this time I make it extra big, and suppose this time I make it be, let's go for an 8-inch line. If I do this 8-inch line, I could come up here and I can measure out here and I can hit Evan.
She can hit Evan.
I can hit 8 inches and come out here and I'll form a triangle. But, this is the amazing part. Couldn't I have also come, yikes, yeah, I could. I could have come over this way and I would hit 8 inches also, and I would have this little tiny skinny triangle over here on the left. So sometimes there's 2 possible triangles out of the deal.
You planned that.
Of course. So the problem when you have a side-side angle situation is you could have 0, 1, or 2 triangles, and we have to figure out how do we check, how do we know which one we got. Okay, the good news is 0 triangles is easy. When you go to work your problem, it won't it'll be a possible value for sine, and you'll get an error which you're trying to use on your calculator, and you'll go, oh, this doesn't work. It's the how to know whether you have one triangle or two triangles that gets a little sneakier. So, let us try a situation here. I got room yet. So now you know why it's ambiguous, more than one possible triangle. Let's try to pronounce it right. Andrew, is ambiguous a senior English vocab word?
No, but it probably should be. Actually, it could have been. I just don't really remember.
I kind of think it is, but I'm not positive.
It wouldn't surprise me. Clearly, it's not one I learned to memorize.
Well, maybe math will help it stick. All right, so I'm not drawing these pictures to scale. I'm just slapped a triangle out there. In this particular instance, suppose I told you that you had a angle A here is 56 degrees. You got angle B, C, C. You know side C is 25, and you know side A here is 9. Is that a side-side angle situation? Yes, it is. You got a side, then an angle. Okay, is it something that will work with law of sines? Do you have a pair, an opposite side and this angle? Yeah. I mean, it sets up beautifully for law of sines. You've got the pair. You don't even have to do any extra work. It's actually easy to work law of sines. Now, there's only one thing, even if I ask you to find some other angle, there's only one thing you can find here. For example, say I had said, find angle B. Actually, make it more exciting. Let's say I had said, find side B. Can you go do side B or angle B at the moment?
How do you know which one's side B?
Side B.
Oh, yeah, cross.
Side B is opposite angle B. So suppose I said I want to find this one. Right now, can I find that one? No. If it's side-side angle, there will only be one thing you could go find. And that will be the angle opposite that other side. That's the only thing we can find right now. So regardless of what they ask you for, you will be stuck finding an angle first. It's a guarantee. I can't do B right now. No, I don't have enough information to find B at the moment. Yeah, once I get more, yes, I eventually can get to B. So, okay, since I'm going to do angle C, you'll notice what I do to the law of sines here I have on the board versus the law of sines we had over here.
You flip them over.
I flipped them over. Why did I put the angles on top? We're going to solve for the angle. So yeah, when you're doing this version, you're going to be finding angles, so you might as well put the angles on top. So we're going to say sine of angle C is to what?
2, 5.
Thank you. And then the pair I know is sine of 56 to 9. Okay. So, how do you solve this? I got to get the sine of C by itself. So I'm multiplying the 25 over here. Okay, here's where you need to pay attention. When you put this in your calculator, you need to put that in there and find out what decimal value that is, because it's going to matter. You actually need to punch in what sine of 56 times 25 divided by 9. And in this case, I should be able to tell you that it's 2.3. Rounded off. It's not exactly 2.3. Okay. If you then need to find the angle, how do you, in your calculator, find the angle?
Inverse.
Yeah, you should be doing inverse sine of 2.3. Somebody want to try doing inverse sine of 2.3? What's your calculator say? No. It's an error. Why? Yeah. Can sine be 2.3?
No.
Sine has to be a number between 1 and negative 1. Sine cannot be 2.3. If you come out with a number greater than 1, you know right there you're done. So this one says error, you can't do it, which tells you it's which situation.
500 to 1.
Yeah, we know it's no triangle. So you'll just flat say, no triangle, and be done with it.
Sorry, 552.
So when it doesn't work, it's obvious. It's very, very easy to tell that you have no triangle. Okay, however, I am going to take that, and we're going to actually do almost that same problem, except I'm going to change one number in it. So, let me draw you another triangle here. And this time, I am changing only, hold it, I didn't correct it. I told you to switch, dude. It still didn't draw with, what is the deal? I said draw with the, there you go, it should self-correct. Right, so we got A, B, and C again. I am still using the 56-degree angle. I am still using this left side is 25. The only thing I'm changing this time is I'm making that side 23. Before it was 9. It was too short and it wouldn't form a triangle. This time, it's a bigger side, so maybe we're going to get a triangle here. So, once again though, what angle am I forced to find first? You have to find C regardless of whatever else you want. You got to find C first. So we're still doing sine of C, 25, and then the sine of 56 that we know, 23. And if you multiply the 25 over to the other side, this time you will get a decimal value of 0.9011. Is that a possible value for sine? Yes, that's less than 1. So we know we have at least one triangle here. It works. You're going to do inverse sine. And this time you will... Oh, well, 9011, thanks. Now I get what you're telling me. And this one will come out to be 64.3.
Are you sure?
Yes.
How sure are you?
99.9% sure.
Really? There's still a little bit of that though. Point one is relatively.
Well, there's always a
large
chance that whatever I have written on my paper is wrong because I trusted a student to punch it in, but
Okay.
I think we're probably good. Okay. So, in this case, I'm sitting here wondering why I wrote this as 64.3 because significant digits-wise, this whole thing is in 2 digits. I don't know why I have it in, unless your assignment has you doing 3 decimals. I don't remember, but okay. There must have been a reason at some point. Because significant digit-wise, we should have just gone with 64 degrees. Actually, I don't care. You want to do whole digits, or you want to do 0.3?
Leave it at 0.3. It's more accurate.
Okay, fine. 0.3 it is. Alright. You now know you have one triangle. You got an answer. There's for sure one triangle. Here is our issue, and this takes some getting used to. Evan, you need to tune into this.
I was tuning into it.
No, you're always talking to Dave, and then Dave can't learn either. Oh, thank you. Actually, this is probably a good point. We will stop here.